Hey guys, welcome to Solve My Math Homework. We're the YouTube channel that solves the math problems our subscribers send in. Today we're asked to look at a graph and determine the intervals where it's increasing and decreasing and to identify any local max or min. So this is going to be a calculus application, but we're going to look at it graphically as well. All right, so when we're asked increasing, decreasing, that's a first derivative problem. Okay, the first derivative of a function tells us the behavior of a graph with regards to whether it's increasing or decreasing. But because they gave us such an easy function, let's look at this function they gave us. First of all, it's slightly weird. They said y equals x squared minus 1 cubed. Okay, so they say consider the graph of y equals x squared minus 1 cubed and determine the intervals where it's increasing and decreasing. Well, everybody knows that the graph of x squared minus 1 cubed is just x squared minus 1. 1 to any power is 1. It's weird that they wrote 1 cubed. I don't know if it's a typo or they're trying to confuse us. Either way, no big deal. And because we're in calculus and because this is a quadratic that we've probably seen since 8th grade, we're going to go ahead and say we know what this looks like. This is a parabola with a vertical shift down 1 unit, right? So here at -1, it's going to look like this. Okay? So when we apply the rules of calculus that we're about to learn, when we apply our first derivative test, we are fully going to expect to see that it tells us this function decreases from -infinity to 0 and that it increases from 0 to infinity. All right? And that's what we'll find out in the end. But because every function we get in calculus won't be this nice, most of them won't be this nice at all, we need to know how to do this using algebra and our first derivatives. Okay? And when I say using algebra, I mean algebraically. Okay, so what does the first derivative tell us? Well, let's talk about it. We are going to first step is going to be to find the first derivative. Okay, so we're going to find y prime. And I keep saying first derivative. Your teacher might just say derivative. But later on, we're going to learn that the second derivative tells us something different about the behavior of a graph. So I will call it the first derivative over and over again because that's what you need for increasing and decreasing. Okay, so we're going to find the first derivative. And then we are going to find the values where the first derivative either equals 0 or where the first derivative is undefined. Okay, so we'll just say undefined. And those are going to be our critical numbers. Okay, they're going to tell us a lot. They're where we start this problem. So let's talk about what a critical number is. Critical numbers are values where the derivative of a function, the first derivative, is either 0 or undefined. The reason they're important is because in between those values where it's 0 or undefined, you'll find places where the derivative is positive and where the derivative is negative. And so where the derivative is positive, our original function is increasing. And where our derivative is negative, our original function is decreasing. So it is really, really, really important stuff, okay? So that's all we're going to do here. It's not going to be too terrible. This is a great page to take a screenshot of or write it down. Know this for your test because it will become very important, especially when we talk about the difference between first and second derivatives. All right, let's get ourselves a clean piece of paper. If y equals x squared minus 1, then y prime is simply what? Well, take the 2 down. 2x to the 1 less exponent is 2x. So 2x, derivative of a constant is 0, so our derivative is simply 2x. We found the derivative. Now we need to find where the derivative either equals 0 or where it is undefined. Okay, let's talk about undefined. Undefined, so values of x that are not allowed. Well, there are no values of x that are not allowed when you're talking about 2x. There's no value of x that you cannot simply multiply to 2. So this is defined everywhere, and that's nice because we don't have to worry about any of these values. All we have to do is worry about where it equals 0. So let's go back to solving the left side. So 2x equals 0, divide both sides by 2. 0 divided by anything is 0. X equals 0. That is the point where the derivative equals 0. That is our critical number that we talked about in that last slide. So our critical number is x equals 0. All right, let's talk about what we're going to do with this critical number. Remember, our original function, x squared minus 1, our derivative, 2x. We're going to take our critical number and we're going to plot it on a makeshift number line. Okay, if you had more than one critical number, you would plot more than one. In fact, if your derivative was a quadratic, you'd have 2. If it was a cubic, you'd have 3, and so on. So it is very common that you don't just have one critical number. All right, so remember we said that when the derivative was positive, your function's increasing. When your derivative is negative, your function is decreasing. So what do we care about? We care about the sign of the derivative. So, oops, I was going to use f prime, meant to use y prime. So we want to find the sign of the derivative basically on the left side of our critical number over here and on the right side of our critical number over here. Okay, so here we're going to say y prime of 10. You can use any number to the right of your critical number. It doesn't matter. Okay, and here we're going to say y prime equals negative 10. All right, so when we put negative 10, we get negative 10 times 2, we get negative 20. We actually don't care about the 20. We care that the derivative is negative to the left of our critical number. Okay? And on the flip side, when we put in 10, we get 2 times 10. We get positive 20. Again, we don't care so much about the number. We care about the sign. All right. So on the right side, we know y prime is positive. So y prime greater than 0. That means f of x, our function, is increasing. Okay, on the left side, we found out that y prime was less than 0. That means f of x is decreasing. Okay, and so we're going to abbreviate that. So let me get a highlighter and kind of show you what's happening here without making too much of a mess of the board. And that might already be too late. Okay, so our derivative is negative on the left side, means our function behavior is decreasing. So this guy is decreasing until we get to 0, our critical number, and then it starts increasing. All right, so that's the behavior of the function. All right, so let's think about this. Anytime you go from decreasing to increasing, what are you creating? What is this critical number down here? If we went from decreasing to increasing, well, then that guy down there is a minimum. Okay, so our critical number in this case is a minimum. Our function decreases from negative infinity to 0, just like we thought it would. It increases from 0 to infinity, and we have a critical number at 0, which happens to be a minimum. All right, if we went from increasing, let's think about this. If we went from increasing to decreasing, then our critical number would be a max in that case. All right, I hope this helped. If you have questions, pop them in the comments section. And remember, I only did this problem because a subscriber sent it in. So if you're not yet a subscriber, hit the subscribe button. And then when you get a problem you can't do, but you need to know how, send it to me and I'll do it. Thanks so much for watching. Have a great one.